Welcome everybody. We're doing practice exam question 1, and for this one we're not using a calculator. It says if for all x, f prime of x, notice the key thing is we already have f prime, it's given, equals x minus 2 to the quantity to the fourth times x minus 1 the quantity cubed. It follows that the function has, and it basically gives me a bunch of extreme value options. So I need to find the extreme. So for this here, we're going to use the first derivative test here. Okay? So what the first derivative test basically says is you want to find where the derivative, f prime of x is 0 or f prime does not exist. And we have our function here. Now the cool thing is you can totally do this within 2 minutes because you don't have to take a derivative. There's no calculus that you actually have to do. There's calculus-based knowledge that you need to know though. So what I'm going to first do is I'm going to check this one here. I'm going to see where f prime is 0. F prime is given already, so I'm just going to say, okay, where is this equal to 0? And as we know from last year, basically each of these values you would just set them equal to 0, and then you would apply the appropriate root. This is the fourth root, and I would take the cube root here, both sides, and then you just get x minus 2 equals 0, so x is 2, so x minus 1 is 0, and x is 1, right? And then so these are what we call our critical values. Okay? So in other words, like the derivative here is 0. Critical means they're basically just important. So these are potential extreme values, and I need to test them into the first derivative test here. Okay? So I found where f prime is 0. There are no values for where f prime does not exist. So now I'm going to make a number line. So now we're going to do a number line. So this is a number line test here. And basically what we're doing, again, this is just the first derivative test. Why? Because we're going to test these, or the points around these, into the, that's right, first derivative. So what we get then, we're going to do, 1, 2, and just make these our barriers, and now we just pick points between them. So I'm going to do, you always want to pick 0 if you can. I'm going to pick, like 1.5, and then 10 or something. Okay? So we're going to plug these again into the first derivative. And the first derivative is already here, which it's given. So I'm going to plug 0 into this equation here. I'm going to plug 0 here. So I'm going to do that right now. So if I do that, I'm going to get 0 minus 2 to the fourth times 0 minus 1 cubed. And what you're looking for is the sign. And remember, if f prime is less than 0, it is decreasing. If f prime is greater than 0, this means it is increasing. And we're going to draw a picture of that in a second. So then we put this in, and we basically get negative 2 to the fourth. This is some positive number times, so this is a positive here. Notice I don't even care about what number it is. I'm just looking positive or negative. And this is negative 1 cubed, which is a negative. Positive times a negative is a negative, so this means this is decreasing. Now don't assume just because it's decreasing here that it will increase. You have to check. Maybe it's just going to decrease again. So we're going to plug in 1.5 into the first derivative. So 1.5 minus 2 to the fourth times 1.5 minus 1 cubed. Remember, we're just looking for the sign. Anything to an even power is positive, so this thing is always going to be positive. And 1.5 minus 1 is positive. And positive cubed is positive, so positive times a positive is a positive. So this means here that this, after here, it increases. And now we're going to check here at 10. And at 10, if we plug it in, so it's going to be 10 minus 2 to the fourth times 10 minus 1 cubed. And what we get then is this is going to be positive times a positive, which is another positive. So this continues to increase, basically. So you can get a very clear picture of what your function looks like. And then you can just basically pick the answer. So clearly, we have a minimum at x equals 1. And now we just look for that in the answer choice. And it looks like it's not here. It looks like I goofed. It says a relative min at 2. That's wrong. That's not true. Relative max at 1. No. So this is wrong. So you would probably want to just fix this. You could say like choice F if you want to. Okay. You would say a relative min at x equals 1. Sorry about that. My bad.